A tank without a turret sounds like a mistake, until you realize it was built on purpose. UDES 03 was not an upgrade. It was an experiment that broke the basic rules of armored warfare. One wrong position and the machine becomes useless. 1 second delay and the opportunity is gone. So the real question is simple. Was this the future of tanks, or the point where engineers went too far? And the answer is not where you expect it to be. If you're interested in tanks, secret military projects, and forgotten war machines, be sure to subscribe to the channel and turn on notifications. There are many more fascinating stories ahead. Enjoy the video, and let's continue. In the history of armored vehicles, developments sometimes appear that do not fit into the usual logic of evolution because they do not improve an existing system, but rather challenge its very foundation. UDES 03 belongs to precisely such cases, where engineers are forced not to refine a classical design, but to effectively reassemble it from scratch based on new battlefield requirements and drastically changed conditions for vehicle survivability. By this moment, the tank as a concept had long ceased to be a simple combination of armor, a gun, and mobility. Each new generation of machines added complexity, increased mass, and simultaneously expanded the spectrum of threats the vehicles had to face. At some point, the accumulation of these changes led to the realization that the traditional layout was working at the limit of its capabilities, and further enhancement of individual characteristics no longer solved key problems, but merely masked them. It is in such conditions that a question arises which becomes the starting point for future radical solutions. What happens if we stop improving the classic tank and try to redefine what it should actually be? This question gradually shifts the focus from modernization to rethinking, where it is no longer enough to increase armor or strengthen armament, because the machine's architecture itself begins to be perceived as a limitation. UDES 03 emerges as an answer to this internal tension between technological capabilities and the limitations of the traditional scheme. Engineers and military experts began to view the situation not through the prism of improving individual components, but through the idea of a complete overhaul of the combat machine's logic. The focus was not on power or protection as individual parameters, but on survivability in conditions where a detection error or a delay in reaction could prove decisive. Gradually, an understanding formed that the classic tank, with its high turret, complex layout, and noticeable silhouette, was increasingly becoming a compromise solution that only worked until the enemy obtained sufficient surveillance and strike capabilities. Amidst the growth of anti-tank capabilities and the saturation of the battlefield with observation systems, this compromise began to lose its stability, and any local improvement ceased to provide a strategic advantage. Against this background, the idea of a radical redesign stopped looking like a theoretical exercise. It became an attempt to answer whether it is possible to maintain the tank as a combat system if those elements that have been considered mandatory for decades are removed. And the deeper this approach developed, the more obvious it became that this was no longer about modernizing existing equipment, but about searching for a new logic of its existence, where every element must be justified not by tradition, but by a specific function of survival in combat conditions. The strategic situation inevitably overlapped with geography, and it was here that the limitations making the classic tank concept less and less convincing for Swedish conditions began to manifest. The country's territory represented a complex combination of forests, lake systems, narrow road corridors, and rugged terrain, where space for the maneuver of heavy equipment was limited by nature itself. In such conditions, large armored formations intended for wide operational maneuvers lost part of their effectiveness just at the movement level, not to mention full-scale combat. An additional factor was that the battlefield was gradually being saturated with anti-tank weapons that were developing faster than traditional armored protection methods. Increasing armor ceased to guarantee survivability, as the threat shifted toward detection and pinpoint strikes, where the decisive role was played not by the thickness of the protection, but by the machine's visibility and reaction time. The high silhouette, characteristic of classic tanks, began to work against the machine itself, turning into a factor that facilitated its detection long before reaching effective engagement range. As a result, a situation emerged in which habitual engineering solutions ceased to produce the expected effect. Attempts to adapt existing platforms to new conditions led only to increased weight, construction complexity, and cost, without a proportional increase in survivability. At the same time, the combat environment itself became increasingly unfavorable for traditional deployment schemes, where open spaces and predictable movement paths played a key role. It was this combination of geographical constraints, technological pressure, and changing threats that formed a persistent feeling among Swedish specialists that further development within the framework of the classical layout would lead not to enhanced combat capabilities, but to an accumulation of vulnerabilities. At this stage, the question of modernizing individual elements gradually lost its meaning, because the problem now concerned not the details of construction, but the very principle of building a tank as a combat system. Against this backdrop, a more radical view of the very nature of the tank as a combat system was formed.
If previously the main focus was on the balance between armor, firepower, and mobility, now another parameter was at the center of analysis: the probability of survival until the moment of first detection. This logic began to displace traditional notions of the tank as a universal platform, capable of acting with equal effectiveness in all conditions. Engineers and military analysts concluded that the key problem was not insufficient protection or weak weaponry, but the machine's own visibility on the battlefield. The sooner a tank is detected, the less significant its further characteristics become as the initiative passes to the enemy. In such conditions, even a technically perfect machine turns out to be vulnerable if its silhouette and layout make it easily distinguishable against the terrain. This led to a gradual shift in thinking from the idea of improving the existing scheme to an attempt to change the very principle of its functioning. Instead of strengthening individual elements, the possibility of redistributing functions within the machine was considered to reduce its visibility and shorten the number of vulnerable points. The concept of a tank began to be perceived not as a fixed construction, but as a set of functions that could be implemented in different ways depending on combat conditions. At this moment, a logic appeared in which the traditional turret and high superstructure were no longer mandatory elements. They began to be viewed as sources of excessive visibility and structural compromises that increased the risk of being hit. Gradually, the idea formed that efficiency could be achieved not through universality, but through strict specialization for a specific type of environment, where the priority was not flexibility of use, but reducing the probability of detection and increasing stability at the moment of contact with the enemy.
When this logic reached its limit, it became obvious that further attempts to adapt the existing scheme no longer provided a qualitative leap. Improving armor, refining the suspension, or strengthening weaponry only compensated for individual weaknesses, but did not change the principle of vulnerability embedded in the classical tank architecture. As a result, a transitional moment emerged when engineering thinking stopped moving along the trajectory of modernization and began looking for an answer to whether it was possible to keep the tank in its familiar form at all. It is at this point that a more radical formulation of the task was formed. Instead of viewing the tank as an immutable design with a set of improvements, it began to be perceived as a system of functions that could be redistributed and implemented differently. This shift in approach opened up the possibility of abandoning elements that were previously considered mandatory, but now began to be perceived as a source of excessive complexity and vulnerability. Against this background, a series of research initiatives under the general designation UDES emerged, where each concept tested how far it was possible to go in departing from the traditional layout. These works were not an attempt to improve a specific machine, but a tool for testing the limits of the tank idea itself. Within this series, a direction was gradually distinguished in which the main emphasis was placed not on universality, but on reducing visibility and radically decreasing the silhouette. Thus began the transition from theoretical discussions to a systematic search for an alternative architecture, where every familiar design detail was subject to revision. And the deeper these studies progressed, the clearer it became that this was not about the evolution of existing solutions, but the gradual formation of a completely different logic for a combat machine, in which previous principles ceased to be the starting point. Within the framework of the UDES research series, this shift in thinking began to take concrete engineering forms, and one of the key directions became the revision of the turret's role as a separate functional module. The traditional turret, providing all-around aiming of armament, was increasingly viewed not as an advantage, but as a structural compromise that increased the silhouette, complicated protection, and created additional vulnerable zones. Gradually, the idea was formed that the necessity of a rotating turret itself could be called into question. Instead, the option of rigid integration of armament into the hull was considered, where horizontal aiming is provided not by a separate mechanism, but by rotating the entire machine. This approach radically changed the very logic of applying fire, as the tank ceased to be a platform with an independent combat module and became a system completely dependent on its position on the terrain. Simultaneously, attention to reducing the machine's profile intensified. Engineers began to consistently remove everything that increased the height of the construction, as every extra centimeter of silhouette directly affected the probability of detection. The layout was revised in such a way as to maximize the closeness of the machine to the ground and use the terrain as a natural element of protection, rather than just as a backdrop for movement. This approach triggered a chain of interrelated changes, where the abandonment of the turret automatically affected the placement of the crew, control systems, and internal mechanics. The machine began to lose its familiar universality, but simultaneously acquired a more rigid specialization, in which the key became not a wide angle of application, but efficiency under strictly defined conditions. It is here that the UDES concept began to finally move away from classical tank thinking and approach a new architectural logic where every element of the construction was subordinate to one task, reducing vulnerability at any cost. When the abandonment of the turret stopped being a theoretical assumption and was solidified as a basic principle, UDES 03 began to take shape as an independent engineering concept with its own recognizable look.
The machine ceased to conform to the familiar image of a tank and turned into a low-profile platform where the entire construction was subordinate to the task of reducing visibility and maximizing the use of terrain as an element of protection. Armament in this scheme was fixed directly into the hull, which excluded the possibility of independent turret module rotation and completely transferred the aiming function to changing the position of the entire machine. This radically changed not only the layout, but also the very logic of using fire, as the accuracy and effectiveness of shooting now directly depended on how competently a position was chosen and how accurately the machine was oriented relative to the target. Reducing the silhouette became the central engineering priority. The hull was designed as low as possible, with maximum concentration of all components within the protected volume.
Any protruding elements were viewed as potential factors for detection, so the layout tended toward a maximally flattened form, where the machine literally merged with the line of the terrain and used folds in the relief as natural shelter. However, such architecture immediately introduced a new system limitation. The absence of a turret meant that any change in the firing sector required not only the operation of targeting systems, but the physical rotation of the entire platform. As a result, combat effectiveness began to depend directly on the accuracy of positioning and the speed of maneuvering. And the crew found themselves in a situation where an error in choosing an angle or cover could completely deprive the machine of the ability to fire at the right moment. When such a layout began to be considered not as a concept, but as a potentially realizable system, it became clear that UDES 03 completely changed the very logic of tank combat. The machine no longer acted as a universal firing platform capable of quickly reacting to threats in any direction, but turned into a tool whose effectiveness directly depended on a pre-selected position and correct interaction with the terrain. In this model, firing ceased to be a function of instantaneous aiming. Instead, it became the result of a sequence of actions where first cover is chosen, then the direction of the hull is aligned, and only after that does the possibility of hitting the target open up. Any error at the positioning stage immediately reduces combat effectiveness, because the direction of fire can only be corrected by rotating the entire machine, not through a separate aiming mechanism. The crew in such conditions found themselves in a more complex role than in a classic tank.
In addition to controlling movement and monitoring armament, they were forced to constantly take into account the terrain, viewing angles, and possible directions of threats, because the construction itself required precise correspondence between the machine's position and the assumed sector of combat. This shifted the focus from reacting to threats toward prior calculation and the competent choice of position before the start of contact. Simultaneously, the dependence on stealth intensified. A low silhouette did indeed reduce the probability of detection at long distances, but this same feature made the machine less flexible in conditions of sudden changes in the situation. As a result, tactical stability began to be determined not only by the characteristics of the equipment, but by the quality of the crew's training, their ability to calculate combat scenarios in advance and correctly use the limited capabilities of the platform.
As the operational logic of UDE SO3 was explored further, it became noticeable that every strong side of the construction simultaneously formed its own set of limitations that manifested precisely in the conditions of dynamic combat. Fixed armament and the lack of a turret created a rigid dependence on the direction of the hull, which meant that any sudden contact with the enemy required not just aiming, but the immediate repositioning of the entire machine. In such conditions, the role of reaction time increased sharply. If classic tanks were capable of quickly transferring fire to new targets by turning the turret, here, any change in the firing sector was linked to a hull maneuver, which inevitably took more time and required more space. As a result, a situation arose where the speed of decision-making and the accuracy of movement began to play a role no less significant than the characteristics of the weaponry or protection. Additional difficulties manifested in crew management. The need to simultaneously control movement, positioning, and aiming led to constant task overload, especially in situations where the environment changed faster than a stable firing position could be prepared. An error in assessing distance, angle, or cover was immediately reflected in combat effectiveness, because correcting it within the current position was often impossible without leaving the safe zone. Interaction with the terrain became a separate factor. A low silhouette did help reduce visibility, but it simultaneously restricted the field of view and complicated orientation in complex terrain. The machine became especially effective only with good knowledge of the terrain or the availability of pre-prepared positions, which reduced its universality and made it less resistant to unexpected combat scenarios where all variables could not be calculated in advance.
At this stage, it became obvious that UDES 03 represented not just an alternative layout, but an example of rigid engineering optimization, where the improvement of one parameter inevitably leads to the degradation of other characteristics. Reducing the silhouette and abandoning the turret did indeed decrease visibility and potentially increase survivability at the detection stage, but simultaneously formed a system in which effectiveness began to critically depend on the accuracy of positioning and the conditions of deployment. If one considers the construction in the dynamics of real combat, a key imbalance appears. The machine wins until the moment of contact, but loses flexibility after it begins. The absence of independent weapon aiming limited the ability to respond quickly to changing threats, and the need to rotate the hull turned every shift in fire into a separate maneuvering action that required time and space.
As a result, the cost of any error associated with the choice of position or direction of movement increased. This dependence on ideal conditions was reinforced by the fact that the actual combat situation rarely corresponded to calculated scenarios. The presence of terrain folds, limited passages, and unpredictable directions of threats made it impossible to maintain an optimal position stably. In such conditions, even a well-designed, low-profile machine began to lose part of its advantages because they were realized only under a strictly defined configuration of the surrounding environment. Gradually, an understanding formed that a radical reduction in vulnerability in one aspect inevitably led to an increase in constraints in others. And it was here that UDES 03 began to be perceived as a system with pronounced specialization, where effectiveness was achieved at the cost of losing universality, and engineering logic collided with a limit beyond which further optimization ceased to yield a stable combat result. Despite the fact that UDES 03 remained at the level of a conceptual design and did not move into serial production, its significance in the engineering logic of Swedish armored vehicles proved to be significantly broader than a specific construction. Such projects are rarely evaluated by the criterion of practical application in unchanged form, because their main function lies in testing the limits of permissible solutions and fixing where the effectiveness of a chosen direction ends. One of the key results of this line of research was a more precise understanding of the role of the silhouette in the survivability of armored vehicles. The idea of radically reducing the height of the machine showed that decreasing visibility could indeed provide significant advantages, but only until it began to limit the field of view, maneuverability, and tactical flexibility. Subsequently, this led to a more balanced approach where height and protection began to be viewed as a complex rather than a separate parameter of optimization. No less important was the partial rethinking of the very idea of abandoning the turret. In its full form, this concept proved too restrictive for real combat conditions. However, some of its elements were reflected in subsequent developments related to the redistribution of armament functions and the reduction of vulnerable zones. Thus, even the radical idea was not completely discarded, but was broken down into individual engineering solutions.
Additionally, the project revealed a fundamental regularity that became an important lesson for further research. Any attempt to maximize one parameter inevitably creates a bias in other system characteristics. In the case of UDES-03, this manifested in the dependence on positioning and the reduction of universality, which ultimately limited its practical applicability, but simultaneously provided valuable information about the boundaries of such solutions. If one considers UDES-03 not as an isolated experiment, but as part of a broader evolution of engineering thought, it becomes clear that its significance lies not in creating a combat machine, but in fixing the limit state of a certain design approach. It was a moment when the traditional tank model was first questioned, not at the level of individual characteristics, but at the level of its architecture and the logic of its existence. Such developments appear when existing solutions begin to lose stability upon the changing of environmental conditions. In this case, the tank stops being perceived as a fixed construction and begins to be viewed as a set of functions that can be redistributed, strengthened, or excluded. It is at this point that engineering thinking goes beyond the framework of habitual modernization and moves to investigating the boundaries of the possible, where it is important not only to improve performance indicators, but to understand which of them are even critical for the survival of the system. UDES-03 in this context acted as a kind of ultimate test. It showed that radical reduction of visibility and the abandonment of the turret could indeed provide local advantages, but only while maintaining strict conditions of application.
As soon as conditions become less predictable, the advantages begin to be compensated for by limitations, and the system loses the universality that in real combat often turns out to be a key factor of effectiveness. This is precisely why the further development of armored vehicles went not along the path of completely abandoning the classical scheme, but along the line of more balanced solutions, where automation, protection, and layout work together rather than to each other's detriment.